Hello everybody. Welcome to another installment on the video series that we have on how to build a REST API application with Phalcon v6. I will reiterate that this is not the way to make an application, it is one way, and we're trying to showcase how Phalcon can help you with its loose coupling, building your application, how you can mix and match different things to make your application more efficient and better in terms of design and testability, of course, and maintenance for the future. In the previous videos, we did a lot of refactoring. We created orchestration objects, the facades. We created an easier way to define services for the Auth Container, the Validators. We moved the user repository. We got rid of different objects that we created before. And today we're going to do a little bit more refactoring in order to make at least the directory structure look better and solve an issue that we created last time around. So let's get started. First of all, we're gonna refactor our folders. I did notice that I've been using singular and plural at the same time in previous videos, and it's always nice to have one way of setting everything up. So you're either going to use constant or constants. You're going to use facade or facades. And of course, if you have objects under this that are in the singular, it actually makes it a little bit weird to see it. So we're going to rename all the plurals to singulars. But also, we have achieved what we fixed last time around, meaning we refactor our code and we made it look nice, but then we started mixing concerns. I'll give you the example. The example is here in the structure. We have infrastructure, which is what the application requires to run in a higher level, and then we have also services here, is what our entry points are, and so on and so forth. But if you recall, in these services here, we actually utilized, for instance, the login post service, we utilized the facade, and the facade is now under data source infrastructure. So it doesn't make sense for this to be here, because this is an orchestration object that allows you to run the code. So facades and services should be together. So what we're going to do is, before we start renaming everything in singular, is we're going to create a new folder here called application. And all of our code will live in there. So what we're going to do is we're going to create a new auth and a new user. And now what I'm going to do is I'm going to put a new folder called service under here. And what I'm going to do is I'm going to copy it down there. And what I'm going to do is I'm going to move these services over there. So these ones will go into the service. Reminder, we're using singular. And these ones will go here. Alright, so now we can get rid of this. And also, what we're going to do is I'm going to create a new folder here called facade, and of course copy it there so that we have the other folder. And I'm gonna move the facades away from the infrastructure folder into the respective application folder. There's that, and delete this. And this one. And now it makes it a little bit easier for us to follow this, because all the initial code that we need resides here in this application where we have different endpoints, and all the supporting code resides in the infrastructure. We will certainly increase the files in here because we're going to do a little bit of refactoring later on, but this is pretty much how we're moving along with this. Now, we did mention, well, I did mention that we're going to name everything in singular, so let's do that. This one will be Sanitizer. This one will become Validator. And DTO can stay there. What else do we have? Yeah, the user part. We're gonna do Validator. And then Sanitizer. Repository. Mapper. Alright, I think we got everything so far. Now, I think we got something in the enums as well. Yeah, let's change the enums as well. Let's keep it Sanitizer here and Validator here. Now, this particular refactoring does nothing as far as the operation of our code is concerned. Our code will run with this refactoring or without. What I'm trying to do here is to make it just a little bit easier for us to read and a little bit consistent. Is it necessary? No, of course not. And do you have to do this? No. If you want to use the plural as your naming convention, or mix plural and singular and so on and so forth, it's entirely up to you. As I was building this as I was building the next iteration of the application, which is this video, I realized that there is a mix between singular and plural, and at the time it was easier for me to see this as singular. If you don't want to do this and you want to rename the folders later on to something different, by all means. Okay, so that's our initial refactoring. Luckily, PHP Storm goes and changes all the references that we have so that it's easier. It's easier for us. We don't have to hunt any files going around. So let's run the tests. And let's see if we broke something, just in case. PHP Storm is really good, but it's not perfect. So always validate with your tests what you need to do. Excellent. Now the next thing that I want to tackle is the container and its definitions. So let's go to the enums container. And here we have an enumeration that returns back an array, and this one is the service definition for our services, and all of them pretty much return the same thing. Also, the container utilizes those, and let me just go up here, and works by registering whatever definition is required. Well, I'd like to change this a little bit and make it a little bit more streamlined. Also, what this change would do is it would go in line with other containers, especially PSR 11 ones, that you have used that usually you don't really register a name, you register the class. And in other more advanced containers where you can specify aliases, you register the interface. And then that one works. For Phalcon, we cannot do that. I mentioned this before. The DI container does not support aliases or auto wiring, so we're going to have to live with it. But in addition to this, there's certain services that are hardwired into or hard-coded into Phalcon. For instance, the request, the response, the router. So these names have to be the way they are, as well as the filter, I believe. Yes. So we have to keep them the way they are, but the rest of the services can certainly keep the convention that I just mentioned and use the actual classes. So let's do something about that. For starters, let's make the registration of these services based on the enumerations a little bit easier. And what I'm going to do is I'm going to come over here and I'm going to copy this and I'm going to call it definitions in interface, and this one will be an interface that extends backed enum. All right, so that's what we need, and we're gonna have, actually I shouldn't have deleted the doc block, should have deleted just this. This, and then we're gonna have a definition, but also what I'm gonna supply here, a second method would be this one will be boolean, and this one will also be public function is shared. Alright, so that's our interface. We're gonna need to return a definition as an array and an is shared as a boolean. Okay, so if we go to the auth definitions now, auth definitions in num, we're just gonna need to say here implements definitions, this one. And of course we're missing a method, so let's add it. And let's go to the bottom. So let's see what services we have here. We have the login post, refresh, facade, sanitizer, auth login, validator, and token validator. So all of these we can just leave them as they are. They're not going to be shared services, so here we're just going to return false, nothing else. Alright, so we got that going. Now, what did I do wrong here? Oh, I forgot. This is going to have to be string. And now for these guys, for now, until we start implementing this, let's put them in an empty string. That's fine. And I know it has an error here and all that. So what do we want to do? We want to use the actual class name for what it's what we're using. Now this particular file has clear class names, and we can actually see them what they are. So the auth login post is auth service. This one is the login post service. So what we can do is we can call it straight up. And actually while we're here, you might have noticed this before. We're calling this in the code auth login post, and here we have login post. Compared to the user, we have user delete. So what I'm going to do is I'm going to rename these to auth login post service, so they're all the same in terms of the naming convention. Clearly, you guys do whatever you want to do and name your files exactly the way you want them. But that was an omission on my part earlier on. Alright, so they're now all called the same. So it goes from auth and then service. So auth logout post service. Alright, so close that. And this one, the auth login post, will be the class name. Class. And you're going to see how this would help us very shortly. Logout post service, auth refresh. We need the auth facade, auth sanitizer, auth login validator, and auth token validator. Alright, so we got this enumeration and it follows our interface, and we have whatever we need here. The issue here is that we want to change the names, the registration names of these to these. Okay, like that. So if we go to our container, we're gonna go and find those services. So here they are: auth login post service, auth logout post service, and auth delete. We arbitrarily put something here. So by trying to make things simple, we ended up making them more complex. We have a constant here that points to a name, and then we use that name to register a service. So instead of doing that, what we're going to do is we're going to delete the auth services here. What else do we have? The auth sanitizer and the validators. Alright, and now if we go back to our code, you see it starts complaining that these things don't exist. But we have everything here in the auth definitions in num. Right? We have everything that we need. So what we're going to do is we're going to create a very small class, a very small method that will take an enumeration and iterate through it, and then register the services for us. Okay, so this one says get service logger. Let's go here and say private function register from enum, and enum will be the enumeration array services. We just leave that, and that one will return an array back. And the signature here would be the string is fine. This one will be an array of string comma service. That's what we're gonna put in, and then we're gonna send the same thing back. So what this is gonna do is it's gonna take the services array here. It's gonna do some manipulations, and then it's gonna return it back. Yes, I could have used this as a reference, but I hate using references with arrays. If you guys want to, go ahead and do it. Alright, so what we're going to do is we're going to say items equals enum cases, because that's that. And this one will be definition enum interface. Now you see why we use the interface as well. And now we're going to need to do a for each on this. Items as definition, and down here we need to return services. So the definition here is going to be an element of this enumeration. So it will be either the auth login, post, logout, refresh, facade, and so on and so forth. Okay. So we know we have two things there. We have the definition and the is shared. So we have to get the service name, and the reason we're doing this is when you get this part here, and then we need to get this part here. So actually this one here, the actual name of the service is irrelevant. We want the value. The value will be the class name. So what we can say is class name, or let's name it service name, because it is a container service name, equals definition value. So that will give us the class name, and this is a string. And now what we're going to do is services service name will equal to a new service definition, and the definition itself will be definition, and then definition is shared. So whether this is a shared object or not. Let's have a look at what we have here. We're receiving a name of an enum, and we're receiving the services array. We're iterating through the enumeration, and for every element of the enumeration, we're creating a new service based on the definition of that enumeration element and the is shared of that enumeration element. And also we're utilizing the value of the definition, which is the class name. But with this way, what we can do is, if we go back to our container, here we have this services. We can change this slightly and start adding more stuff. So we can add more stuff the way we want them to be added. And of course, we're gonna do here this services equals services. Okay, but we haven't done anything. We just move the services here. But here, if we do services equals this register from enum, and then we put auth definitions enum class, and then pass the services into it, it's going to start iterating through this definition and start registering everything. So the ones that we deleted, these three, and then these two, and this one, and the facade, are going away. Right? So we're simplifying the code a little bit by utilizing an enumeration and doing the registrations the way we want them to happen. There you go, this register from enum. So let's go back to let's go now to the common definitions. Let's see what we can do here. In the common definitions, we're gonna return this a string and implements what is it, definitions in interface. So the events manager here, let's have a look at our container. Where do we have our events manager? It's here. The events manager is a reserved word. We were looking for this in in Phalcon. So we're just going to leave it as is, and what we're going to do is we're going to say equals container events manager. All right. The JWT token is just a class that we have, so we're going to put the definition of the class there. All right. Same thing with a cache. Same thing with the manager. All right. And the router will remain as is because it is a reserved word container router. All right. So now let's have a look. Events manager enable priorities, great. This container env, JWT token cache. So far it's looking okay. And the router. Now the one thing that that remains is we need to implement the is shared, right? Let's correct this little error here. And in the is shared, out of all of these services, we need the self events manager and self router to return true. So these are going to be two of our shared services, and then default equals false. All right, so we got these four. Just in case, let me keep them around so that let's close this. Come over here. All right, so we got rid of the JWT token, the token cache, and the token manager. These four, right? So we got rid of these three, and now we have the events manager and the router. Okay. Let me quickly see something. The events manager. Yeah, the events manager is fine. No. Okay. Just double checking. Alright, so we're shrinking this thing a little bit. And we need to come here and remove these three definitions. We're gonna leave the router the way it is. Alright, so the router has that. That's the name of it. And then it goes there. Okay. So what we're going to do now is we're going to do the same thing, register from enum. And this time we're going to use the common definitions enum. So this one will register the router, the events manager, and the other three. So immediately from these things, we just get rid of the events manager and get rid of the router, because those are registered in the enumeration. Okay. Now, the next thing we need to do is we need to have a look at some of these guys here and see how we can utilize them. So we said we're going to start using the names of the applications of the register services. So it's going to be the logger class. Shoot. All right, I forgot the user. All right, let's do the user and then we'll go back to the common services. So the same story here with the user definitions num. It sends a string back and implements definitions num interface. Let's add the method stubs. And for this one, we're gonna have equals user delete service. User get service, autocomplete for the win. User facade. Okay, I don't know if this is not a class. User facade update. All right, let me leave it empty here for a moment. User repository, sanitizer, validator, and validator update. Okay. So other than the user facade update, the rest of them point to actual classes. And we're gonna comment the user facade update. We're gonna deal with it a little bit later. Yes, if we run the tests now, they're gonna fail, but bear with me. Let's go to our is shared. If you look at these are the same as in the auth, so they're kind of like one-offs. So for the is shared, what we can do is we can return false. We don't need these to be shared services. All right, so that one is fine. So we leave these here. Let me just comment the user facade update for now, so we don't have any errors being thrown here. That's fine. And now let's go back to the container. What we're going to do is I'm going to clone this and say user definitions in them. So that one will do the users. So by doing this, we're getting rid of these, this, and these. So significantly shrinking our code, and all these constants, we don't need them. User repository. Gotta deal with the mapper, maybe. Let me check my notes. No, we don't have to. We don't have to deal with a mapper. We don't even have to deal with the responder JSON. Because since we're going to be using the names of the classes, the DI container will automatically create them for us. So we can get rid of these facades here and the services. We can get rid of the mapper and the responder JSON. And I'll explain how that works in a moment. So since we're using the names of the classes, we're going to get rid of validation, we're going to get rid of security, we're going to leave router, we need it, we're going to leave time, response requests, those are reserved words, we're going to get rid of the registry, the logger, we're going to keep filter, events manager, we're going to get rid of env, connection, and cache. So these are going to be the names of the services that we want, and we're going to replace the rest of them with the name of the class that they're creating. So for this one, the self cache, we're going to do cache, which is the Phalcon cache class, and this is how we're going to refer to it from now on. Connection class. Oops. And I'm saying refer to it because this is gonna be what the application will look for as far as the DI container is concerned. The env will be the env manager class, and note here, we did say that if you use the class name without having a service registered, it will generate that class, it will create it for you. But in this case, for the env manager, we're actually registering it ourselves, and we're setting it to true. Now, I could easily take this and put it in the common definitions, which, yeah, I could do that. Actually, let me do that. And why not? So, where are we? Let's take these guys. And then common definitions, sorry. So what we're gonna do is we're gonna have case env manager will be env manager class, and then let's have a look. Case request equals request, it's the Phalcon HTTP request class, and then it's the case response, and then we need the registry, of course. Now for those, for those, we can just leave them as they are. They're gonna be just the name registration. We can just add them here with their own little array, and their array is gonna be very simple. But the key is we want them to be registered as shared. Okay, so let's have a, it's these three in the env manager, right? So self env manager, and then the other three we're gonna put a comma here. Right. Now, as far as their registrations are concerned, I could easily put them in the container and just say new service, so on and so forth, but let's follow the enumeration. So what I'm going to do here is for the env manager, here I'm going to say it's going to be a class of env manager and nothing else. So it's going to have just a class name. That's it. That's the whole definition. And the same thing will happen with registry, request, response, and router. Okay. So let me just copy this. Let's go down here. Registry, request, response, registry, request, response. This is response, and this is request. So all these are gonna be registered the way they are, and in our container now, registry, request, response, go away. Also forgot the logger. That's it. Now we're going to be referencing that as the logger class. Now, we did remove a lot of things, and this is the key here, how we're going to tie everything together. And since we said that we're going to be using class names, apart from very few ones, like the filter, for instance, our code has to change slightly. So for this get service cache, we no longer have this env variable, so we need to use the class name env manager. And now if I ask the container for the env manager class, it will give me an env manager class. Not only because it can create it, but because we have defined it here as the env manager class will be the env manager, meaning this, right? And so in order to access any other service, we're going to have to use their class name. So again, here we have another reference, and don't seem to have something there. We have another one here. All right. Now let's have a quick look at the other services that are defined in the other enumerations. If you notice, we had some errors highlighted by PHP Storm. So let's go to the auth definitions in NUM, and here we go. All right, so this one, the auth login post, correctly points to auth login post service, which is perfect. But it references two things: the facade and the validator. So in order for us to do that, since we're going to have class names, we're going to have to change this to the auth facade class, and this one will become the auth login validator class. That's the change we have to make. Equally, user repository Auth Sanitizer. This is my TokenManager, and this is the security. And for this one, we have the filter. The filter has its own name. This one is a validation class, the validation class of Phalcon. And again here, the TokenManager, user repository, and again the validation class. Let's go further down. So here we need the Auth Facade. And then the token validator. So now we're referencing class names all throughout the container. Let's check the common definitions. We have here the env manager. Here we have the cache, and it's this one. You're gonna have to match the class itself. So let me just copy this one. It seems that we need to put it in a few places. Here we need the token cache. JWT token. Okay. Router response and so on and so forth. Now, what we will need to do also is just to be careful about what we define as shared and not shared. We certainly do not want to define something not shared and have it reinstantiated again and again and again in by the paths that our application takes. So for instance, we have injection of the env manager. We know that we have that as shared, so it will be created once and then reused. But the token cache and the token manager and so on and so forth, as we inject them into different components, for instance, down here we had it injected here when we have the auth facade, and then it's somewhere here if we have the auth token validator. All right, well, the question is the facade and the validator going to be instantiated at the same time. If that is the case, then it makes sense to keep the token manager shared, right? Because this way one of them is going to create it the first time, and then the other one will reuse it instead of creating it twice. Okay, so these are the things that we need to do to ensure. And in this case, this is a prime example. Let's say you're going to the auth login post service, right? This doesn't look correct. Hold on. Let me check the notes. That's not it. This is the one. So the auth login post service. What does it require? It requires the facade and the validator. Okay. That shouldn't be the auth login post service. It should be the auth login validator. There you go. Okay. Copy paste issue. So this one here, the auth login post service, requires the auth facade and the auth login validator. All right. Okay. What does each of those need? So the facade needs repository, sanitizer, token, and security. Great. What does the validator require? It requires a token manager, repository, and validation. So let me just shrink this and shrink this. Let's put them together. All right, so you see we have user repository here that is common, and we also have the token manager, and then we have a validation class. So it makes sense for the token manager and the user repository to be shared because they're not going to be created all the time. So common definitions, token manager is there. So all we have to do is come here, self token manager, and then comma, and that's it. It might be, I guess it might be easier to define which ones are not true because events manager is, this one is token and the token cache are not, and then everything else is. So it might be easier to just do this and then everything else returns true. Because we want the router, response request registry, and token manager, env manager, and events manager. Yeah, we want those as shared services, and the other two we don't really care that much. And this is how we set this thing up. Now, remember, we need the user repository as well to be shared. Okay, so coming back to the user definitions in here, let's set everything up. So let's forget the facade for now, the update facade. Let's put the same one and we'll correct it in a little bit. User facade class, user sanitizer. And the previous exercise was to actually show you that you need to figure out the paths that your application takes and how your objects are being created. If your objects can be shared and reused throughout that whole path, then you should do so. Otherwise, you're literally wasting resources. User validator class. user mapper class, and I'm going to come to this one in a minute. Repository class and security class. I might have made a mistake in a different security, but we'll see. All right, something to point out here. This user mapper class, right? It used to be here in the container as a definition. Mapper equals this, similar to this definition here. And all we had to do is just call it from the container and it would be created. Well, leaving it like here does exactly the same thing, because as soon as this thing starts getting processed, it will check, do I have a user sanitizer class definition? And if not, it will just instantiate the class. If there is, it's going to use that definition. Same thing with a validator, same thing with a repository. But the user mapper is a small class that doesn't accept anything in the container, in the constructor. So it will just create it. Same thing with the security. Okay. Now, if we see them and we need to have them shared, we will do so. For this one will be the connection class. And this again is the example of let's leave this for a sec. Let me correct these two and I'll come back. Facade class, and here we have the validation. All right, so here's a key. The user repository is a class that we needed to be shared, right? And this class, if you notice, is used by the facade, but the mapper is here and the mapper is there too. So it is evident that not only the mapper needs to have its own definition, it has to be shared, but also the user repository. Because once this gets created, a mapper will be instantiated and be put in there. But if that one is created to be given to this guy, then another mapper is going to be created here. So we're doing double the work. Also, this is an indication of whether we have designed this correctly, because if a mapper is used in the user repository, what is the mapper doing in the facade? Shouldn't the mapper be in one spot? So these are questions that we need to answer in our code and see the flow, how it goes. So let's quickly do the user mapper and the user repository. So what I'm going to do here is I'm going to do somewhere here, case user mapper, and that will be user mapper class. And for our is shared, what I'm going to do here is I'm going to do return, match this. I'm going to put these two guys in there. So the user mapper, we need it to be true. There we go. So now those two services are true, and we can definitely call everything that we want by using this this enumeration and the refactoring that we did. So our container became 250 lines of code. And most of it is just the registrations of the cache and the connection and so on and so forth and the logger. So these 3 lines actually do a lot of work for us. Now, the last thing to check is, because we did all this, we have a lot of unresolved references in the code. So if we run the tests, everything will just fall apart. But we also have this middleware. And the question is, do we really need to have this middleware here? Or can we use these classes, right? So let me copy these and just take them out of here. And where do we use that middleware? If you remember, we use them in the routes enum down here, and we also use them in the actual middleware definitions. They have their own definitions, so let me copy them here and change their definitions. Let's put that, and the other ones, I guess I can get them. So we have presence. I cannot copy them. All right, well, I tried to do a mass copy, but it won't work. Health middleware. This is token presence. This one is the structure. User. And the last one is the revoked. Alright, so what's the story with these guys here? Well, we used to have a name that was pointing, we used to have a constant that was pointing to a class. So now we just have the class, right? This is what it's going to be called. And here, now we have different things that we need to address, because we no longer access these by the constants, we access them by their class names. So this one will be auth login post service, auth logout, and then this one will be user delete, user get, and user post. Alright, so this is the mapping that we do here with regards to the routing. The route, this route matches this service. Alright, now let's go and have a look at our middleware, because that's one of the places that we know that we're referencing services. And also let's have a look at the providers. So the providers are here, and I know for sure that they accompany the container, so they do reference different things in the container, and you know they're running there too. All right, well, as expected, we need to change these references. So this one will be the class, and the logger will be logger class. And I don't think we have any more references here. All right, in the router provider, let's have a quick look. Application and events manager remain the same. We have something here. Here's the interesting thing, the responder JSON. So the responder JSON is attached here, and it is injected in the action handler, which is created here, right? If I just add the the name of the responder, that will be it. I don't have to create it anywhere else. And that's it. That's all I need to do. I don't even have to have it register because the DI container will do this for me, right? So now that we've done that, let's go to the middleware. All right, so down here we have something. Again, responder JSON is for this. Now, we could make the responder JSON shared because it's used in the halt, and it's also used in the main application. So whenever you have a halt, you already have another JSON container, another responder JSON. So that is a good way of knowing that you're creating the same object. All right, so let's go to our common stuff, the enumerations, container. All right, so we're gonna do here. And we're just gonna leave it like that because the default is true. So now the JSON responder is gonna be shared, which means that this object will be the same as the object that we got here in the routes. So this one will be the same as that because this responder is attached to every action handler that we create, every one of these guys, and it gets put in there and just waits until you do the response. But when you do the halt, when something happens and the middleware stops, it creates a brand new one. So we don't want that. We just want something like this. All right, so the abstract middleware is fine the way we want it. Response there. Let's have a look at the rest of the middleware. I'm pretty sure we're gonna find some references that we need to check there. So this one says request. That's perfectly fine. Not found, doesn't have anything that we need. Validate token claims. Oh, there you go. So this one requires the JWT token. Okay. And this one requires the registry. Excellent. Token presence needs the environment env manager. Token revoked needs the cache. And the registry. Nothing else. Structure. Okay, and here we have the registry, and let's see the user. Excellent. All right. So now we're referencing everything with regards to their class names, and the benefit is you know exactly what you're getting. You don't have any cryptic names and all that stuff. You even know this when you're doing get request, right? You know that this is the request object, but But what we did is here in the container, we significantly removed the lines of code and we made it much, much simpler, to the point that the services are being set here, especially the ones that are a little bit complex. They need configuration, so on and so forth. The filter is not that complex. I mean, it just creates its own self, but that's a different story. The logger here also needs the env manager to get some environment variables and all that stuff. One could easily employ different strategies on how to get that information. There's for other containers, there's the option to put these environment variables in the container itself as properties, and then just read those property values. So many options exist. We could optimize this application until the end of time, and still it's not going to be perfect. So instead of doing that, I'm going to leave it at this, because I want you to see the way of thinking, how things evolve. And actually, didn't I move this in the other one? Yes, I moved this in there. So I don't even need to have this. There you go. So now I have cache connection, filter, and logger in here. I pretty much don't even need the request and the response, or maybe I do. Yeah, I do, because I utilize them here, or not. There's a mistake. Yep. Okay. So I need to register request as request and response as response with lowercase. So so these two are essential. So if this one, what it does is it puts the name here, and then it needs the definition. All right, let's make a small change here. These should not be the classes, they should be the constants. There we go. Alright, so the objects are going to be registered as request, lowercase, and response, lowercase. It's going to come over here, and it's going to pick up what class it needs to do, and they're going to be shared. So that fixed that issue. But yeah, that's our container here. Very nicely done. Let's run our tests just to make sure that we got everything. I'm sure we didn't, but okay. Unhandled match case. Alright, we forgot to put something in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have a feeling it's the responder. Yeah, it's the responder. Let's do this. This, and then JSON like that. Okay. Unhandled match case of this. Where's the unmatched case? 139. Why is there an unhandled case? I reading this right? User definitions. No, okay, it's the other one. What did we do here? We put the mapper in. Probably that's what it's complaining about. Yes. The mapper should go somewhere here. We're gonna do this and then call this mapper. And then this one will be user mapper and then no arguments. There we go. Alright. We have different references. You see now we're looking at these variables, these constants from the container, which is fine. But these are primarily in the tests. Alright, this is the one. Yes, I do remember I made that mistake with the security component. So in the auth definitions in so look, there you go, Phalcon encryption security. That's not the one that we need to use. We need to use our security object. This one. Alright, the rest of them are just constants. Alright. And of course we have the cache tests and all that stuff. Okay, not bad. 91 errors. Let's go real quick to the JSON responder test. I'm not going to bore you with fixing all these. I'm just going to fix them off camera, and then I'm going to come back. So this is what we're trying to do here, JSON responder class. So if there should be another one here. So if I run this, out of 91 it should have 89 or something like that. There you go. So this is what we need to do. We need to go to the tests and just change every reference that we have to other objects. I'm just gonna do that off camera and then come back. And with our video editing, I've managed to change all the definitions to use the classes, and the tests are passing. Actually, I do have one that fails, but that's intentional. Let's have a quick look at the validators now. And the reason I want to do that is because if you recall, in the in the insert part, our validators required that the email would be present and it will be a valid email, or the other elements will be present. So when somebody submits a post, we definitely need to have password, the issuer, the token password, and the token ID. So all these are required. On the update, we did the same thing, but this is wrong, because when we send an update, we might send a different set of fields and only some of them. So the one that definitely needs to be there is the ID, because we need to know which record you want to update. But every other one needs to be checked only if it's present. Okay, so I could send an email and an ID, but the password issuer, token password, and token ID might not be present. So this validator will fail if those are not present. So in order to sort that out, we need to make a small change here, and we're going to utilize the allow empty method of the validator interface. Allow empty equals bool. And now for our user, which one? The update. Okay. All right. So for this one, we need to remove the presence of, because that's not there, and the default will be empty, and the allow empty will do match, so self ID equals false, so that one cannot be empty, default true. So everything else other than the ID could be empty, right? In the insert, this is easy. We're just gonna return false. And of course, in the other two, we're going to return false as well. So when we get the token has to be there. Cannot be well, we got the presence of here, but this one satisfies the interface. And for this, again, return false. They do have the presence of and all that. So this one, the update tells us that the ID cannot be false, and the presence of satisfies that as well, and it has to be an ABS int, and the email could be empty, but if it's not, then it's an email. Right? So now we have to go to the validator class. This is application, infrastructure, data source, abstract validator. Let me consult the notes as well. Yes. All right, so we have to figure out how we're going to wire it here. All right, we're getting all the elements from the validator, and then we're just running through them, and then we're getting the validators for each, and then we're iterating through them. And the validator object here that we're creating needs to have allow empty equals element allow empty. So what this will do is it's going to construct the relevant validator with allow empty equals true or false, depending on what we want, and then the rest of the code remains the same. One more thing we need to address is with the middleware, and I noticed this when I was changing the references. The middleware, if you notice, it accesses the JWT token, and we don't want that. We want to access the TokenManager in order to be able to do whatever we need to do. So the change is simple here. TokenManager, and this one will become TokenManager. And now this one becomes TokenManager validate. And if you notice, this one returns an array. So this change is easy. For this one, we don't need to do anything. For the revoked, we have cache in manager and registry. Great. For the structure, we have JWT token here, so we need to change that. And here, the JWT token object, we do have a get object, but if we look at the signature, it returns either a null or a token. So it never throws this exception. So this code can be simplified, or can be changed if you like, by checking for the null. Let's split them up a little bit. This, and then now it will be as simple like that. And here now we don't have an exception. We need to throw something. So we need to know what kind of change the TokenManager, what kind of error the TokenManager has in order to be able to throw it. Okay? So let's go to the TokenManager. And for that, we're going to have to add a little bit of functionality here. So we're going to say private string error message, right? And we need also right. And now here, what we need to do is we need to store the message. So we're going to make sure it's always empty when before we get the object. And if there is an exception, we need to put ex here. So we have that variable over there. Let's do this and then this. We have this variable here. Before we make the call to the get object, we're going to make it empty as it was. If get object is successful, it will remain empty, but if it's not, it's going to throw an exception, and we're going to grab it here, and then we're going to store the get message. Of course, let's not forget, where is it? If we go here, I made a change and made it TokenManager interface, but when we added this, the get error message here, we did not add it in the interface. So I made sure that I added it here as well, so that it abides with everything that we have here. So now we're in good shape, and let's have a look on one more thing. And this is going to be an additional refactoring that we'll have to do. And if you've been following this series, you're going to realize how we ended up here. So if you recall, in the application service, we had user delete, we had a bunch of code here, we moved it to the facade, which is our orchestration. And the same thing with the get service and so on and so forth. So now the facade is here, and we're injecting certain dependencies here that are not always used by all of them. So delete doesn't use security, for instance. Insert and update does. But still, the issue that we have here is that we had all our code in the action, and what we've done is we shifted it all here, and now this one is the big class, and it comes down to 350 lines. So this one becomes what is called a God object. So something that we have here, and it has so much code that we cannot touch it. The easiest way to refactor this and to make it so that it's expandable as much as possible is by splitting each of these methods into their own components that would receive their own injections and dependencies and so on and so forth, and will do everything. And also make sure that our code follows one simple path, and every single file that PHP loads has only the code that that particular component requires. Because if you think about it, loading this loading and interpreting and loading this this class, PHP has to deal with 300 some rows, and it uses only a quarter of them, maybe. So lesser files is lesser processing per se. Of course, the arguments would be, with OP cache, this is completely negligible and all that stuff, but it's always a good practice to try and optimize your code as much as you can, even by not letting PHP process more than what it needs for a certain path. In the long run, the more you do it, the more your applications are going to become more streamlined. There's always the argument of, this is a stupid micro optimization, all that stuff, but it's not an optimization per se. It's a way of thinking, and if you're thinking about that in this manner, then further down the line you're going to find a place where that particular micro optimization, if you want to call it, actually did save you a good amount of time. So this is at least my mindset. I suggest you give it a shot. It doesn't hurt. So what are we going to do about this? Well, what we could do is we could introduce a way where the factory creates a component or a class that deals with each of those actions. Okay, and in order for us to deal with this, in order for us to be able to route everything, we're going to use the command pattern. So in every one of these methods, we're going to create an object, a command object, and then we're going to dump that object into what is called the CommandBus, and that CommandBus will be responsible for calling the necessary handler. And imagine, if you want to imagine what the handler is, it's this method here. This could be one handler, and that would be responsible for returning everything back to us. And the reason we're doing it this way is what I mentioned before. We're going to split this this class into smaller components that will do only one thing. So only one of them will do the delete, only one of them will do the update, and so on and so forth. And this way we're going to be able to delegate the task somewhere else. Now there's plenty of CommandBus implementations out there. One of them, which is a really good one, is the Tactician by the League of Extraordinary packages, I think, phptheleague.org, I think. And that one implements many strategies of finding your target class. So one command to target class, one command object to target class. And it also introduces middleware. Now we're not going to go down that route. We're just going to create a very small and reasonably efficient command class. And after that, we're just going to leave it like that. And after that, what you guys can do is either replace it with that, or use something else that you might want, or enhance it. It's entirely up to you. This is just a way to show you how we're moving through this maze and trying to optimize our code as much as possible. At the same time, we're building this application. So what we're going to do here is we're going to create a folder called CommandBus. And in here, we need to have, for starters, we need to have a transport object. And the transport object, let me just copy a file here. Doesn't matter which one. We're going to call it command interface. Again, the phone. Alright, so this is going to be our command interface. And what this will have is nothing. We're just going to keep it here because we want to kind of like group our commands to follow one particular interface. And a command will be a value object that we will transfer from the facade all the way to the command bus, and based on that object, the command bus will know which handler to call. Will it be the delete handler, the insert handler, and so on and so forth. So the command bus itself will need to have its own interface. We're going to come back to the command interface in a minute. So we need a command bus interface. And the command bus interface is going to be simple. It's going to be actually, this is what I forgot, and I think this one is the same. Yeah, it should be an interface. Apologies for that. And here we're going to have public function dispatch, and then we're going to have command interface command, and it will return a payload. That's what we have here. And now we're ready to implement the command bus. Final class. Right. And the command bus will be simple. It will have that, and then what it needs to do is it needs to locate the command, the relevant handler. So in order for us to run this, we need to have a class that will be able to locate what the handler is. So here we go. We need to create a different class. Sorry. So how are we gonna call this? All right. So let's see. Let's create an interface that will be handler interface. And then what this interface would do is this interface would be followed by all the handlers that we will have in the back, all the way in the back. Meaning, what I have in the here in the delete, all this is going to be part of the handler, but the handler needs to have an interface. So this handler interface will be public function invoke. It will receive a command interface with a command, and it will return back a payload. So all of our handlers will have to use the invoke command. Okay. So now that we got that, we need the glue between them. So we need to make the locator. And let's make the interface for the locator. So handler locator interface, and that one will have a method called resolve. You can name your methods whatever you want, and once you resolve that, you're not going to return a payload, you're going to return a handler interface. So when I run this locator and I resolve the command, I'm going to get a handler interface. And when I get the handler interface, I'm going to call invoke on it to get the payload. Okay. So now our command bus changes a little bit, because now what I can do is I can inject the handler locator we need the handler locator interface, and that's our locator. I need to close it like this. And now that we have the handler locator here, we're gonna do this locator resolve command. This one will return to us a handler interface, and then we're gonna need to run the command in that handler, and this one will return a payload interface or a payload. We're extending the payload here. We could have done this with our own payload interface. Make our class a decorator. Actually, we might do that. Make our class a decorator of the actual Phalcon payload. But for now, let's just leave it as is. It's just fine. So this is our implementation for the command bus, and that's all the command bus needs to do. It needs to accept the locator, and then when you run dispatch, it accepts a command, resolves the command to what handler we need, and then it runs the handler with the command that we passed, and that returns back the payload. Okay. And you just love interfaces. We created the command bus code without even having the locator code yet. So the locator is going to be it's going to be an implementation that does a simple substitution, if you want to call it. So what we're going to do is we're going to rename a class that is passed, the class name. We're going to rename it the part that says command to the part that says handler. And I'll explain that in a short while as soon as we start creating our folders. And once we do that, then the handler class will be able to do everything that we need it to do. But before we do that, we have to create our commands. So what the heck are these commands? The commands are going to be data transfer objects that we have, and they're pretty much getting the input and then transferring all that data all the way back to the facade, and then the facade just does whatever it needs to do with handlers. All right. So let's go to our user and let's create a folder called command, and let's create our first command to see what we have here. We're gonna call it user delete command, and the name is important here, as you will see. Alright, let's get rid of all the craft that we have from the other copy. So it's going to be found in read-only class, and this one will implement command interface. Remember, the command interface is empty, but we just need to do that. So all we have to do is public function construct public int id. That's all we need. What are we doing here? Oh, of course, that one. Alright, so for the delete, all we will need is just the ID, right? Imagine this one grabs the input, alright, whatever we want to get as the input, and equally, same thing would be the get, right? Because in the get command we just need that. Now later on in the get command we might do a get many, right? So we can increase the parameters of this object. For the post, it's a little bit more elaborate. So what I'm going to do is I'm going to copy it from my notes here, just to save us a little bit of typing. And then for the put command, it's the same as the post, but with one difference. And the difference is that the int is standard. It's not nullable. So this is the put, this is the post. Actually, this one should be different because it's int null there. So this is the difference between the two. This one has null int as the ID, but this one doesn't. Okay, so these are all our command objects. Okay, let's concentrate on the get one. So in order for us to have this object, we need to make a change, especially in the facade. Okay, so here, let me shrink this guy so that we get the user. Here what we need to do is we need to get the command, create the command, and then pass it in the CommandBus. Okay, so how can we do that? Alright, well, in order to create a command, the easiest thing, instead of doing new command this, new command that, is create a small factory. So let's create a factory here, which will be 5. We just need the factory interface. And then that one will have a few things. Let me just copy it because I have the types as well here. I didn't copy the types properly. Alright, so this is going to be my interface. The factory will have it get, delete, insert, and update. And what we're going to do is, once we have the implementation, that, let me do the same thing again and copy, and I'll explain what that is, because it's a little bit intimidating in a sense. There. All right. Data source interface. Domain infrastructure. API domain infrastructure. This is wrong, and this is wrong. Missed the S. Yep. Okay, so user command factory, what it does. We're going to what we're doing here is we're delegating the sanitization, or however you want to call it. We're just cleaning up the data a little bit of the input into this object, and then after this object we're creating the necessary command object. Okay, let me see what that is. It should have been sanitizers interface. Really? I got something wrong here. It's also interface. There we go. The abstract value object. So let's have a quick look at the facade. Let me just close some files here. Just give me a moment. Alright, so the user facade. Again, mistakes here. There we go. Let's do the get. Right. So we're receiving all the input. We're creating a user input transport, or DTO rather. And then from that, after it's been sanitized, we're getting the user ID. And then we're doing whatever we need to do here. Okay? So in the user command factory, because we said we're going to delegate that there, we're still passing the sanitizer. And in the get, we're doing exactly the same thing. And then we're returning a get command. So we're just doing this part here. And we're wrapping the DTO into our new object, and we're sending everything back. Equally, the same thing for the delete, the same thing for the insert, and the same thing for the update. Now, the difference is that here we're just doing a user get command with DTO ID. This one, of course, we're going to have to pass more properties so that the user post command can be created. And the difference here, of course, is that on this one we send null because it's an insert. On this one we're sending the ID. So this is our command factory on how that will allow us to create different command objects based on whatever we need. Alright, so how would this change this code?
we're going to have to invoke it, and we're going to have to take all this code and move it somewhere else. Okay, and this is the thing that I was saying, that we need to be able to map one to another. So we're aiming to create the glue. So what we're going to do is we're going to move these to the handlers, wherever they're going to go, and then we're going to concentrate on doing the glue, which means from the action it goes into the facade, and then a facade it goes to a command object, and then command object goes to a command bus. Command bus sends it to the handler, and then you get the response back. It might sound as a lot of steps, but you might have noticed it by using the command factory. Immediately we're removing sanitization from here completely, right? And also if we had something like Tactician, the package that I mentioned from PHP the League, which is a command bus, that one I mentioned allows for middleware. We could have attached that middleware to our command bus to run validations. So these validators could have very well be in that part of the command bus before it even reaches our handler. Remember what we mentioned: if you exit early, if your code exits early on an error or a condition that was not met, it's far better than just going the whole trip and then coming back, right? So we're not going to do that part of the validation because we don't have middleware in our command bus. Our command bus is very simple, but it gives you an idea of what we could have done if we had additional things to our disposal. All right, so let's create a handler. And for this handler, I'm going to cheat and copy the facade there. All right, clearly the handler would be a final. I don't need this. Read only. Implements handler interface. And we're just going to need to delete. We don't need the rest of them. And here we're going to need to implement what? Let's come over here, add method stubs. You come up there. Alright, so this is our signature command interface, which will return that. Clearly we do not have this anymore. It's command, and we need the repository here. So our constructor changes slightly to this, and we don't need this read only. Alright, so I just moved that class over here, and it was dead easy to do so. And let's do the get as well, and we're gonna concentrate on the other two in a little bit. So again, I'm gonna copy the facade because that one is the one that has our code. It's gonna be final read only. Implements handler interface. We're gonna add method stubs, and we're going to get rid of the delete. That. We're going to leave the get, of course. Going to come all the way down here, bring this up, and come over here. Alright, so in this case, again, we don't need the input, and what we're going to do is command this, and all we need is the repository. So that, this, and then that. There we go, and no read-only here. So we just moved to our code to commands. We still haven't taken it out of here, but that will happen in a minute once we move all the commands. And what I was mentioning earlier about the command locator, it's going to be a simple replace between the word command and handler. Look at this: user delete handler, user delete command. So once we know the name of this class, we're going to be able to locate this class.
Let's do the same thing for the post and delete and put. Copy again the facade. User post handler. This is post. That's weird. Right. Actually, just leave that there. Read only. Handler interface. Stubs. There, and we don't want the delete because we already have it. Same with the get, and this is gonna be this. We don't need the user validation, we just need the command. Here. As far as the pre-insert is concerned, do we have it down here? Let's get rid of this class as well. We have an error somewhere, of course. Yes, it's here. So now it gets anything. We're gonna worry about these two, the command objects, even over there. Invoke is here. Pre-update needs to go away. All right. Pre-insert some stuff, and we don't need the sanitizer. We just need that. I guess we're gonna need the validator interface as well, which is there, mapper, repository. I'm wondering, will we need the registry? It doesn't seem like here. We might need it in the other one. So we're going to copy this facade too, and then this one. User put handler. And actually, let's copy it one more time and make it abstract
user put post handler, and I'll explain why. This is abstract there, implements handler interface, and in this one we're not gonna need the sanitizer. We're gonna need the validator, mapper, user. We might need the registry, but that's fine for now. So we need to get these two out, or three. This one too. We're gonna make this protected. We're gonna make this protected. Certainly don't need to use the pre-insert or pre-update. And we're gonna have the process password. Alright, so these ones, we have an error somewhere. Abstract class, leave those read-only. That's perfectly fine. So in the post, we're gonna take that one out. Can we have read-only from? I don't think we do. I don't think we can do this. No, we can't, because it's the abstract. Alright, so this one doesn't need a constructor because the constructor is in the other side. This validator, let's see. Don't we have a validator? We do. Curious one. Oh, these are private, of course. So in the post, validator is fine. This is fine. This is fine. Cleanup fields already exists in the abstract class. So is get error payload. Pre-insert is fine. And then we have process password. So that's how this one becomes. And for this guy, let's take extends abstract user put post. Let's get rid of this. We need to implement the interface. Let's take it from down here. Should be somewhere here. And we need to go down to update. Made this. No need for the sanitizer. We're gonna copy the command here, and here, and here. So far so good. And we get rid of this because it exists in the abstract class. The insert pre-update and the process password needs to go away. Repository, yep, that should be fine. So we just brought all these handlers here. Yes, we have some errors. I mean, validate does not accept the command interface object. It accepts different things. Let's do our little code blocks. And here. This one has its own constructor. We could put this one in its own abstract get delete, so it has just the constructor, but it doesn't matter for now. We can just leave it here. It's not a big deal. So what we've done is we copied the contents of each method here, the insert, get, delete, and update, and we transferred them all into different handler classes that no longer accept an array, but they accept a command interface. And the commands are up here, which are the ones that translate what comes into to our handler. So we need now to work on the locator, which would pretty much pick up one of these four, and manipulate the name in order to derive to one of these four. This is why we have a user command and then the user get command, and we also have user handler, the user get handler. So our command handler locator, or we can call it container handler locator. Actually, that one would be better because it locates items using their the name that they were registered in the container. So we're gonna have to copy this, and we're gonna call it container handler locator. So it's gonna be a final read-only class. Of course, implements handler locator interface. We're gonna have that. We're gonna have public function construct, and in here we're gonna have private di interface container. So we're gonna pass the container in here. And there's been a lot of discussion in the past whether we can pass or we can't pass the container in a service. This is not trying to hide any dependencies or trying to utilize services with the locator, and pretty much those services are transparent to outside. This one is used just to locate a specific class from a specific service. So in this scope, this is perfectly fine. So what we're going to do here is we're going to say command class. We can do get class command. Actually, yeah, probably it's going to be fine. So handler class equals str replace, and in here we're going to have command, and it would become handler. Yeah, command will become handler. Actually, that's nothing else. It's like this. Command class handler equals this container get handler class, and this one will be handler interface. And now we need to return the handler. So it's gonna pick this class here, which will be Phalcon API domain infrastructure CommandBus. Phalcon API domain application user command / user get command, and it's gonna replace the word command with handler. So we're gonna end up with a API domain application user handler / user get handler. So that's how this whole operation works. And now that we got this, the CommandBus is the one that is making this translation. We did a lot of this here. So we did the commands, we did the container handler locator, we did the handler and the handlers, and so on and so forth. We still have code in the facade, but before we move forward, we need to proceed with registering everything in the DI container. which is down here. So we're going to go to our enumerations, and since we have user related data, what we're going to do is we're going to go to our user definitions in them, and clearly we will need to register the handlers and the commands. Okay, so let's see here. We'll leave the user facade update out completely. We don't need it. So what we're gonna do is we're gonna do case user command factory. Okay, we have user delete get post put. We have the user facade. Now let's put the handlers. Alright, so these are all our classes. We have a good amount of them. And now we have to figure out what we need to do to register them. Okay, so the very first thing that we need is the user command factory. We have the facade and these. Okay, I'm just copying these so that I can have something. So the user command factory is this. It will be class name, of course, and then we have arguments, and type will be service, and in that one we'll need to do sanitizer class. And we're gonna have to think whether sanitizer needs to be shared or not. Let's have a look down here. We have to see where it's being injected, if it's injected more than once. We can get rid of the user facade update down here. We don't need it, and you're gonna see why. Alright, so we got the user command factory. We're gonna work on the user facade in a minute. So let's go to here and paste. And it's gonna be this is my class name. Like that. And then like this and the comma. Alright, so the delete handler receives the user repository. So let me copy something here so I can set it up. And the same thing with the get. Now, the user post handler has a few more services. Let's have a quick look. Alright, it's the abstract put post handler. It needs validator mapper, repository, and security. I think we can make this class of its own, a method. Alright, so user post handler, so the post will need the validator. Second one will be mapper. Third one will be the repository, and the last one will be the security. And this, I can put something like private function get post put definition string class name is an array, and it will be return this. Like that. Let's fix this one, and then this one will be class name. This one will be string, and this one will be service, I guess. Alright, so up here, user post handler will be this get this definition, and then user post service. It's a different class. Actually, we can do this. And this one will be the user put handler. Now here's the interesting part. Before this we had the user facade and the user facade update, and the reason we had that was because we were using the validator for the user and the validator update for the post and the validator update for the put. So if we do string class name and then string validator name here, and we put the validator name here, then this one changes slightly. Let me just fix this. This one changes slightly. If I go back up here, we need the validator name. So for this one, it will be this validator, but for this one, it will be the other one. So it's a common definition, but we want the update validator for the second one, the put, and the normal the other validator for this one. And by doing this one, we got rid of the user facade update. Okay, so we have user sanitizers, the validators, and everything we need. So now we've just registered all these. So what's going on with our facade? All right, well, the facade will require a couple of things. For starters, how do we end up in the facade? Let's look at the workflow as it goes. We start from the action, and then we go to a service. Let's go to the application service. So user delete service, and we're calling the facade with this input. Okay. Now, inside the facade, we need to be able to distinguish what we got, utilize the factory, and then be able to dispatch back the relevant command class to the command bus, and then the command bus will invoke the locator, and then we're gonna find who this thing is for, or which one is gonna be um, the actual class that needs this, right? So if we're looking at the what you call it, that the user delete service, this thing doesn't change at all because he's still gonna call the delete. All right, so let's go to the delete class in the facade here. We need to utilize the command, right? Okay, so how do we do this? Well, for starters, we need the command interface. All right, so let's do private command bus interface. Let's call this bus. Let's get these guys out of here. So how are we gonna get this this object? All right, so return this bus, and we have dispatch, and now we have a command here. But how do we create the command? Well, it's easy. We're creating with the command factory, so we need to have the command factory injected here. User command factory interface factory. So here's how things become really easy. So dispatch wants a command, and we don't have a command yet. How do we create one? We create it with a factory. This factory, and the factory has its own little methods that create different objects. So we're going to utilize a delete, and we're going to send the input inside. A reminder, the command factory, the delete, will return a user delete command. Okay, and now all of this goes away. Equally, we're going to copy this, and this one will be get. And this one will be insert. And this one will become update. There we go. And now the other commands, the other methods, we really don't need them. Pre-insert, pre-update, process password clean fields. Okay, they're all gone. So our facade has been reduced to very few things that we need. Let's redo the CommandBus interface, and if we go back to our definitions, the user definitions, now the facade changes to we need CommandBus, and then we need user command factory. That's all the classes that we need. So we got rid of the second facade. We now have the validators hooking up straight to the handlers, and we're passing the command bus and command factory to the facade, and that's how these things work. Now let's be brave and run the tests. Of course, we're gonna have tons of failures. This one says user service put test. Alright, so we're bound to have some problems with figuring things out and what's going on. For instance, the CommandBus construct expects different things, which leads me to believe, did we create the CommandBus service? Did we define it per se? If we look at our enums, let's go to the common ones, and lo and behold, we don't have the CommandBus. Alright, so case CommandBus equals class. And what are we gonna need for the CommandBus is what? Let's just copy this thing just to have something to work with. So we're gonna need a CommandBus class, and for the arguments we're gonna have a type will be service, and for name we're gonna have to put the locator. Alright. Now the container handler locator, this one will require this, so this class here. Question is, where did I register that? I don't think it will work. This one needs the DI interface here. I have to find this. Well, this one requires the container itself. So most likely it's gonna be, well, not most likely, it is gonna be here in this one, because this one we have access to this. Let's make a name here, and let's go somewhere here. Alright, so what are we gonna return for this? We can actually return an array, but let's do the function part. Return new container, and then press this in it. Alright, so this is accurate now. We have the service handler locator defined, and it's going to be used by the CommandBus, and CommandBus is going to be used by the facade. Okay. Alright, let's run the tests again. Oh my, 66 errors. Still 66 errors. Alright, we have a problem with this. Let me do a quick search for the word interfaces. It's not interfaces, it's interface. We used all the singular of the words. It's a little bit better. Okay, we expected some errors. It's not a big deal. We've got to figure out all these things here. And we have abstract user service. The facade must be of user facade. Validator was given. Okay. Abstract user service. Doesn't tell us where it's coming from though, does it? User post service. Okay. We need the user definitions. Let's find the user post service here. User get service should be the same. A user put service rather. Just sending the facade in it. Okay. Okay, that one's there. 9 and 2. I'm not sure if I fixed it, but let's have a look. These last errors, I know exactly what they are. It's work that we need to do to satellite classes. This one complains again. User service post test 61 and user post service 31. Okay, let's find the user post service, what it needs, real quick. This one. So it runs the abstract unit user service, which requires the facade. So there's nothing wrong with that I see, unless we have wrong references anywhere. This looks like it points to the right place. Alright, we'll find that in a minute. I don't want to delay this a lot. It could very well be the test. Alright, test service success. Empty dates. Arguing one facade must be of this, but we give it a validator. Right? Do we have an error here? Okay, so user get post put. These are the services. Facade and then delete get post put. Okay. The facade is there. Someplace we're sending the validator. And I don't know which one it is. Get post put definition. Let's go up. This is the post handler and this is the put handler. Of course, there it is. We have here user put handler and here we have user post service. So we need the handler to be here.
but we need the post handler. And now if we run the tests, we should have a little bit less. Okay, 8. Not bad at all. This DB, I know what it is. We're gonna fix it in a little bit. DB again, DB again, DB again, DB again. Excellent. Alright. So all of our definitions are correct. They're pointing to the respective classes. And now this DB that it's complaining, it's the translation that we have in any of these that allows us to change, let's say, a database record to a domain record, or in our case it's going to be a command to whatever we want. Let's say a database record. So command locator is gone. So we're looking for the mapper, and this one would be under infrastructure, user mapper. So this user mapper needs to change according to what we have changed things for. So now the mapper does no longer gets a user input, it gets a command. And let's have a quick look at one of the handlers, not the services. Alright, so if you see here, we're getting a command now, and that command needs to go to the mapper, and that needs to return a user, which is an array tailored for our usage. So if I go to the mapper again, for starters we're gonna need to do the DB one, and this one will be a command interface. And of course, command interface here. Alright. So back to the mapper, if we have command interface here, we're gonna need to get all these, which are correct already. And if I go to the user post handler, now you see DB is just perfectly fine. But that's not all. We need to work on this validate, because the validate doesn't really use a command. So if we look at the validator, let me just double check my notes here. Which one is this? The post. So we need to go here in the validate. It's gonna be the validator trait. Under user. Alright, so let's open our notes. So the command here, the input is actually a command. That's what we're sending. Let's copy this, and the run validations will still be command interface, and command interface here, and the same thing with the validator update in the validator. So this one will be fine, this one will be fine, but the abstract validator now is the one that requires a little bit of love. So we have the validation interface. Now in this case it will be command interface that comes in, and then in the command interface what do we need? We have input here, validation validate. We can make this command. So that one will work with a command, and this is the Phalcon validation, which will work with an object like this. It doesn't have to be an array, so we're doing well here. Actually, here in the validator trait, let's rename these command, because it makes it a little bit easier to know exactly what that is by its name. And now we expect to have some errors. The user mapdb error will be gone, but there will come a validator error because I haven't touched the ones in auth, and lo and behold, this is the, I'm pretty sure this one is the one that will tell me. Alright, so it needs a CommandBus, a command there, but user validator trait in 29. Okay, so validate here, and let's see, abstract validation. Oh, we have the validator interface. Where are interfaces? It's not there. Here, this one. This one is the one that complains. Command interface. Command. Command there. Oops. Alright, so now the interface is the same. I'm expecting errors from the auth, of course. Alright, so there you go, refresh post service. Again refresh, again refresh. Abstract validator. Other than those, these are all validation tests. Alright, that's great. These are all validation tests. So if I go to the auth validator and I change this one to command interface and make this command, and pass the command here, that's done. If I go to the token one, do this, here, here, and then this one here. And also we need command token. I think we need to put a mapper here, a variable, just to make sure that this is what we need. I'm pretty sure it's the token thing. So we have string is token, and var will be auth log out post. I don't have the commands yet. Alright, well, we're gonna do it in a little while. Let me put it to do. The doc log or command here. Alright, so we're gonna run this again. Clearly we're gonna have errors, but at least there are not going to be interface errors, so the interface should align. Okay, this comes from the facade. the Auth Facade, same thing. Yep, these are all the same thing. Alright, so the next thing that we have to do is we're gonna have to work on the Auth Facade. Let me close a few things here. Leave the validator open, user mapper. So we're gonna have to work with the auth and do the same thing. Have the handler here, and then create the commands and use the facade over here. So we're gonna have to do two folders and just split the commands and split the facade into respective handlers. So let's create the auth commands just like we did with the user. We're gonna come over here and create a new folder, command, and while I'm here, handler, and let's grab one of these. We're gonna name it auth login post command, and the auth login post command will have two things here. We need null string username and null string password. That's our command. We're going to do the same thing for the tokens login, for the login token, login post, logout post and refresh post, and those will have just the token in them. Logout post command, which will have token, and refresh. Alright, and here the factory will be Auth command interface, and this one will have actually, let me copy it because it has imports, so let me copy it from the other side here. It saves a little bit of time with the imports. Alright, so we're gonna have authenticate, logout, and refresh, similar to what we've done with the facade, of course. And the actual command factory would be like this. Implements, and in here we're gonna have again the sanitizer. Now for these guys, we're gonna have the following. So for the authenticate, we're gonna have do equals auth input new this sanitizer and input, return new login post command. Here you go, the email and the password. And for the other ones, we're gonna have this, and then the command would be auth log out post command, and the parameter will be token. And this is going to be the same thing here, but this one will be the refresh. Alright, there's our factory. Excellent. Alright, now we have to go to the handlers, and I'm just going to copy a handler from here and put it there. Auth login post handler, and on this one we're gonna have to get whatever we have in our facade. So it's this part here. So let's copy. And we're gonna put it here. Some imports. And we're missing certain things. So for starters, we don't need the sanitizer. It's fine. But what we're missing is the security and token manager. So user repository, token manager, security, and we need the validator as well. These injected, this one will become this validator. This is going to be command. This is going to be command as well. Also command. And yeah, this looks fine. Let's do the same thing with the logout. Actually, before we do this with the logout, let's create a common abstract. Abstract auth logout refresh. Abstract. I'm gonna keep the constructor the same, and let's copy one here, and let's make it auth log out. So we get rid of the constructor. But what do we have in the logout? We have this. And we have classes to import. Alright. We don't need the DTO here. We have a command here. And we also have a TokenManager there. Alright. So in our abstract, we're gonna need to have okay. We need to have the TokenManager. Okay. And we need the validator. These two. Alright, so coming back, we got this. Now we're in the logout. And these ones we need to put them read-only here. Alright, so we're getting everything. This one will be this validator. Oh, of course, they cannot be private, they have to be protected. So this one is fine, and the TokenManager is fine. And now let's do the refresh. And back in the facade. Alright. So this one goes away. We have command here. And this one becomes this validator. Alright. Perfect. Alright, let me... Okay. Now, to close the circle, so to speak, we need to go back to the facade. And up here, we're gonna need to to inject the CommandBus and also the factory, exactly the same way that we did with the user. So I'm gonna make this read-only here. Private CommandBus interface. Let's call this bus, and then private auth command factory. These are the two that I need. And now our code changes to something really easy. Buzz, dispatch, this factory, authenticate, and then we're gonna throw the input in there. And we're removing quite a bit of code here. And this authenticate now does not need the validator anymore, because the validator is in the factory. So I'll just copy this line here. authenticate, it will be logout. And of course, this one will be refresh. And this is our whole facade. Finally, we're going to need to do something with a container. Of course, we need to register these services. Let's come to the auth definitions and start defining what the facade is and what the factory is, and so on and so forth. We're going to do pretty much the same thing that we did with the auth, with the user side of things. Right. Plugin posting. Facade. Let's do the handlers. We're gonna need to do. I think we need to do the commands. These are our handlers, so we just need to add these services. Let's copy this one. Alright, so this one will be the command factory, and it needs this, but also we're gonna need the sanitizer. That's one done. The login logout post. This one gets an invoke. Login post service, facade and validator, facade and validator. I need to check these services here. So just a moment. Alright, let's go to sort out the facade. So the facade is here. We know for sure that it takes the command bus. That's one. And it takes the factory. That's it. Those are the two ones that the facade needs. Alright, the facade is done now. We need the handlers. So let me clone this and put the handlers in there. So this one will be the auth login handler. Handler. Let's double check what it needs. Repository manager, security, and validator. repository, TokenManager, security. This is the post, so it's gonna need the login post, so it's gonna need the auth login validator. There we go. And let's do the same thing for the logout. So the logout post handler needs what? Needs token and validator. Token, and it's gonna be the auth token, that, but this one I'm just gonna copy it. What I'm gonna do here, this get and have this one. Like this. Down here somewhere, get handler service, return an array, and it will be this here. Because the the refresh and the logout have exactly the same definitions. So small utility class here, method here, just to do this. And up here again, we're just gonna clone this, and this one will be refresh handler. And of course this one too. Alright, this is the login post handler. Great. Now we need to address the services: login post, logout, and refresh. Okay, so now we have to look at the services, the auth login post service, logout, and refresh. So let's have a quick look. Okay, the validator doesn't exist anymore here because it has been moved into the handlers. So all we need here is the facade, and of course we're gonna remove it from here, from the calls that we make to the facade. And this one. Alright, so the three services are done, and this one. And in the definitions, in this get service, all we need is the facade. So at the top here, we were using a different definition in order to pass the different validator. Well, we no longer need this. All we need is the same call here with the auth login post service, and then this one goes away. There we go. So the get service will just inject the facade into those, and from these guys here we're gonna have the different validators. You see the validator has been moved here, and for the other ones, for the token related ones, it has been moved down here. So we just shifted the validator a little bit further down. Let's run our tests and see what we got. 1.9. Okay, let's have a look. Auth login validator test. I have a feeling that this is in the actual test. This is a problem in the test, not the code. So we need infrastructure, data source, auth validators, auth login validator test error. Oh yeah, of course. We're testing the user input where this one will be the command. Okay, let me correct all the tests. And then I can come back, or actually let me do this first one so that you guys can see how I'm changing them, and then I'll do the rest of them, the ones that have the reference to the input, and I can do that off camera, or yeah. So for this test, what we need to do is, we don't need the sanitizer, we don't need the validation, we need to make a couple of changes. So we're gonna do validator equals this container get auth login validator, and factory, we're gonna use the auth factory, auth command factory. Alright, so this one is auth command factory, and this one is auth login validator. So now we got these two. What we need to do is we're gonna say user input equals factory authenticate input. So now the user, actually let me name this user command, not even user, sorry, it's auth command. And now in the validator, we don't need this because we have the validator over there, and then it will need to validate the auth command. Right, so we had 9 errors, 4 failures. If we run this again, eight errors, 4 failures. So we just fixed this, and if I copy this to here and copy this part to down here, like that, I should have 7 errors. There you go, 7 errors. All right, so let me fix the other tests, the ones with the token, and I'll come back. And we're back. I managed to write some tests specifically for the commands. Very simple tests, just making sure that the actual oh, this is for the factory. Some of these commands that you just send an email and it keeps it and whatever, and some for the factory, just to make sure that we do get what we expect. I wrote also some of the handlers. They're pretty much the same as the ones in the service, because without all the layers. In pure test-driven development, you would first write the test and then you would implement the functionality. So the lowest point of execution, which would be deep in your application, will be your handler after the request has gone through, initially the router, the dispatcher, the middleware, and so on and so forth. So you just write all those tests there, and maybe you would or you wouldn't write some service tests, meaning that it comes before the command bus and so on and so forth, and the facade. Uh, it is some duplication of tests, but it's perfectly fine. Your experience and your strategy on writing your tests varies, so you can decide what you want and what you don't want. Um, I'm gonna do one last thing before we close, and then off camera I'm gonna push in the repository some other changes. So the changes that I will push later on will be tests for the enumerations. So what I want to do is, remember we discussed in the past that I like testing the full enumeration, especially if it's something like flags, where I use the actual values of the enumeration elements as lookups in my database. This way, I know nothing changes. If another developer, let's say, changes a number, I know that my test pass failed. So I'd like to create enumerations for the services just to make sure that I have them all together. It is a huge overkill, but I'll just put it up there for you guys to have in the repository. That's a to do after the end of this video. The last thing that I want to do is a little bit about the input and the sanitizers. And I thought about this, and I wasn't doing a good sanitization, meaning when let me pull the sanitizers here. All right, so for the Auth Sanitizers here, things are fine. It's filter email, right? For the user sanitizer, we have ABS sent an email, and then here we have string. The string filter in Phalcon throws an HTML special chars on the actual value, and that shouldn't be the case. What we should really do is make sure that this value is a string, and also if we want to, let's remove any potential bad characters from it. So the more appropriate sanitization technique here would be strip tags. So by putting strip tags here, it's gonna get rid of all of the nasty elements. Clearly this is not a pure sanitization technique for our data. All right, you can have more layers on it, especially if you're having submission from forms such as a text box. That is what you see is what you get, so something like an editor field. We're not doing the sanitization, the strip tags on password token and token password. We could, because but we'll have to change a little bit our technique. Here, all the passwords that we have been generated by this method here, get strong password. And what it does is we talked about this before, it creates a really long string of random characters, and in it has some of the characters that will be considered as HTML and will be stripped. So we could potentially put strip tags on the password and the tokens and all that stuff, assuming that we removed all these characters that could be considered dangers by the strip tags method of PHP. So if we shorten this special sequence to have not less than, greater than, and a few others, then we could certainly use the strip tags on the password token and so on and so forth. The theory is that
these ones, since this is a user of the API, we're going to create that user, and we're going to allow them to use our API. Yes, we do have a post endpoint, so somebody could submit data, but later on we might have some sort of an admin panel, and we decide that, and we don't give permissions to anybody to do that. But it's entirely up to you how you want to proceed with your application. I'm going to utilize here the strip tags because it's better rather than the HTML special chars. I'm pretty sure that the tests will fail right now because I have some comparison somewhere there. But we can fix that real quick and then do our recap. There you go. You see how it was setting it and how it is still now. And I did the corrections of camera, the power of video editing, yay. Let's see our tests. One more. User service post test. Post test would be 360. 360 here. Alright, so this HTML special chars needs to become strip tags. And make sure that the preferences is null. Okay, so we should be fine here. Alright. Code coverage, let's make sure we're at 100. Excellent. Composer CS, just to make sure that we're following code sniffer. And composer analyze, it's the last thing that we have. No errors, excellent. So let's quickly recap. We made some folder changes. We changed everything to a singular form, so interfaces became interface, validators became validator, the folder names, and we kept everything together. We also split the folders from the infrastructure. We moved some things out of it, and we made the two areas here, the auth and the user, and in those we put the application specific code, commands, the facade, the handlers, and the service itself for each of those two, and then the rest of them we left them in the infrastructure. We took our facades and we split them into much smaller and more manageable classes, and we developed a CommandBus to utilize the routing and dispatching of those handlers. Each of those methods in each facade was transformed, if you like, into its own handler. By doing so, we found opportunities where we could move the different validators into the handler, so the facade was just being a pass-through. We made some significant changes in the container, primarily for the services that we could, the ones that are not hardwired to
Phalcon, we changed their names, and we utilized the class name for each of those services, and we made all the changes throughout the code. And of course, we implemented for the CommandBus, we implemented the command of each endpoint or each action, if you like, and those are being transferred to each handler with the necessary data for everything to execute. And of course, we did our tests and all that stuff. And yeah, that's it for today. This is pretty much the end of this application. We're not going to make any changes functional per se to it. The next video, what I would like is to pick up a new area, potentially will be companies, and I can make the CRUD for a company. I don't know if we have time. I need to time this because I don't want the videos to be very long. We could do company and an individual, or company and invoice, something like that. And we can introduce another endpoint, being the list, because sometimes you might want to get more than one. In the users part, I left it specifically just one when you're doing a get, but we can certainly implement the list. So that would be the next video, and that would close all the series of this. That will close the videos of all these series, and the repo is going to be there for you guys to clone, to implement, enhance if you like, and so on and so forth. All right, and with that, thank you very much, and see you on the next one.